Hey everyone, today we're going to learn about forces. There's two main questions here. First is, well, what is a force? And the second is, how can we visualize these forces? So let's get started. Well, what's a force? A force is a push or a pull on an object. Okay. So a push or a pull on an object. It's really an interaction between objects. So one object will push on another object, or one object will pull on another object, and they'll push and pull right back at each other. So forces are an interaction between objects. And lastly, forces, they can be contact or non-contact. So let's go through a couple examples here. So let's start with contact. Example of a contact force would be, let's say you are pushing on a desk. You push on a desk. Okay, and I'm going to underline you and the desk because it's an interaction between two objects, you and the desk. Another example would be, let's say you are going sledding, and we'll use that example in just a moment. So you pull, if you're pulling on this rope which is attached to the sled, you pull on a sled. So you are applying that force to the sled, and that sled should begin to change its state of motion. The other example, or the other type, would be non-contact. So let's go through a couple examples there. Non-contact. Let's say the Earth, you might already be familiar with this example. The Earth pulls you down. The Earth is pulling on you, and this is the force of gravity. So the Earth is exerting a gravitational force on you and is pulling you towards the ground no matter where you are. It is non-contact. And so this force can act really from really far away. And this is how, let's say the moon is orbiting Earth and the Earth is orbiting the sun. This force can go over very long ranges. So another example here would be, let's say a magnet. Let's say you're holding it and you're bringing it towards the fridge. So magnet pulls toward your refrigerator. And the objects here would be the magnet pull towards the fridge, and this is called the magnetic force. And let's say you got two magnets, and maybe you've played with magnets before, and you push them together, and you feel that force of repulsion. So it could be a push as well, depending on how those magnets could be oriented. Okay. So to kind of go over things again, we have a push or a pull on an object, which would be the definition of a force. It's also an interaction between two objects. And these forces could be contact or non-contact. Let's go to the other question. How can we visualize forces? Well, we can visualize forces through the context of free body diagrams. And we'll represent that as FBD. So free body diagrams, well, what are they? What they do is they represent, or they show, all forces on a single, and I'm going to underline that, single object. So let's say we've got more than one object in the system, and we want to represent all the forces on each of those objects. We can't do it on one free body diagram. We would have to draw as many free body diagrams as there are objects. So all of the forces on one object is we can represent it using a free body diagram. So let's get to an example here. So let's pretend that we're going to go sledding. All right, there's a bunch of snow on the ground, and it's a great day to go sledding. And right here, we have a sled. Notice I didn't actually draw a sled. This sled is just represented by a box. We're not going to draw pictures here, just a box representing our object in our system. So here we have a box, which is our sled, on the ground that's full of snow. And this sled is sitting there under the force of gravity. It is at rest. Its state of motion is at rest. So if gravity is acting on it, it is pulling that sled down towards the center of the earth. And we can represent this. We can't forget to label our forces here. So this force is the force of gravity, F subscript G. And gravity is going to pull our sled, it's going to try to pull it towards the center of the earth. Well, it doesn't really make sense if the ground is pushing back up, right? So if the ground wasn't pushing back up, that sled would accelerate towards the center of the earth. So we have another force here. So the ground is applying a force back up, countering the force of gravity, and we call this the normal force, F subscript N. The normal force, what that does, it's always perpendicular to the surface. And this normal force pushes back up against gravity with the same amount of force as gravity. Because if it didn't, that sled would accelerate straight down towards the center of the earth, and that wouldn't make much sense. But those forces are equal, and if we took the net force, meaning if we added those two forces together, one being positive, one being the force of gravity being negative, in the opposite direction, we would add those together, we would get a net force of 0. So let's add some more forces here. We got our sled again, and we still have that force of gravity. And that normal force is still pushing back up on our sled. But now it's time to go sledding. We need to drag the sled to the top of the hill. So we have a rope attached to the sled, and we start pulling on. And we apply a force, and this force, since we're pulling with a rope, we'll call that F of T, the tension force. So since we're pulling on this sled, there's tension in that rope, and it's applying a force this way, which we're trying to move the sled or accelerate it in the same direction. But you notice that, well, that sled is getting really, really hard to pull. There's a bunch of snow on the ground, but what's causing this? Well, you might already know this as this force being friction. F subscript little f, the force of friction. This force, it is responsible for a lot of things. It's responsible for us being able to hold things. It's responsible for us being able to get a good grip on the ground when we're walking. But it's also responsible for inefficiencies, slowing things down, making it harder for us to do daily tasks. In this case, if we're trying to pull the sled, this force of friction is trying to oppose that force that we are pulling with. So if we're trying to move it this way, friction wants to oppose it in the opposite direction. Friction opposes sliding, okay? So, and there's a lot of different, there's a few different reasons why friction is the way it is. Well, it could be because maybe we have two objects that are really rough and you're kind of dragging them across each other. It could be the molecular level where the molecules are very sticky, and but that could cause increased friction. So, and this is what we have, is we have the force of friction that opposes motion, and we've got the tension force, which is usually in ropes or strings or chains and that sort of thing. We have the force of gravity that's pulling down, and then the normal force, which doesn't always have to oppose gravity. It could be in other situations as well, which we'll get to later, but it is always perpendicular to the surface. There's a few other types of forces that we're going to get into, but just remember that all these types of forces are all forces and they will all have the same units. And we haven't seen what the units are. So the units for force are newtons. And a newton is represented as N, which is also equal to a kilogram times a meter per second squared. And in a little while, we will get to understand why a newton is equal to a kilogram meters per second squared, but I'm going to leave it at this today. So we have forces, they're push or pull on an object. They are an interaction between forces. They can be contact or non-contact. And we can represent these forces on an object by using free body diagrams. And all the forces are represented on one single object. So that's it for today. In a little while, or the next lesson, we'll get into Newton's first law and law of inertia. All right, take it easy.